This short video is going to be on chapter 1, the ether, and I'm really not going to go into a whole lot about that because there's plenty in the book. I just want to kind of give a basic feel for it. One of the most important things to understand is that many of the skeptics who continually quote Michelson-Morley as having proved that the ether does not exist are quite simply ignorant of history. If you want to know what the truth is to the ether and what has been proven, there's one person's work that you need to check out, and it's Dayton Miller, who'd even corresponded with Einstein quite a bit, and towards the end of Einstein's life he even admitted that he was never sure he was on the right track to begin with, and he admitted that with Dayton Miller's findings, if those are true, then basically his whole model falls apart, and the only thing that remains is the equivalency between inertia and gravity. Now, there is one particular paper I would recommend everybody go online and read, and it's by Dr. James DeMayo, and it's called Dayton Miller's Ether Drift Experiments, and that's ether spelled just with the letter E, E-T-H-E-R, and that's one of the most important papers that ties together the history so you can actually see what the sequence of what happened, all the original, the foundation of electrical engineering science, especially as taught by Eric Dollard, showing and uncovering what the real history is that a lot of the foundation to it is based in the ether, the tubes of force, or the etheric, tubes of induction, based on a lot of Faraday's work. Some of it can kind of get a little bit kind of complicated, but a lot of that was basically covered up. But I just want to encourage everybody to search out Dayton Miller. And quite simply, the ether is fairly unknowable. It is theoretical, but we are able to do experiments that not only measure the existence that there is something there, but also be able to generate real work out of seemingly open space, or apparently empty space, but it's not empty at all. And just real simply, if you just consider the ether, if this is open space, or so-called empty space, which is not really empty, all the ether within there, we want to consider it to be symmetrical and homogeneous, which means it pretty much has the same consistency throughout, and that there's no real potential differences in there. There's a positive and an implied anti-charge to the ether. There's different models of the ether, but to keep it simple, look at it as a bipolar pair, which is a very symmetrical soup. In the quantum physicist language, somebody maybe like Tom Bearden would say it's basically the virtual photon flux at a quantum mechanical vacuum. But going back into like the Faraday or the Tesla language and a lot of the stuff that Eric shows, basically it's the ether. They're all talking about the same thing using different language, and in the quantum key we're going to be using the language the ether because that is what it is. That's the original term for it. It was never disproven, and we're going to be walking through various chapters that's going to tie all this together. Again, it's important to understand that it's symmetrical. And the whole thing about turning ether into work is making it symmetrical, which means you have to break the symmetry, or you have to polarize the ether, which means you create a high spot and a low spot within the ether. And we're going to be going over exactly what those principles are and how to do it, because that's foundational to every bit of energy. And we're going to go into the difference between energy and potential. And what the ether is a pure potential, but it's important to understand that potential, the way it's typically used, is used as an abstract, while people talk about energy as being the thing. Well, that's completely erroneous, and in fact, energy is not a thing at all. Energy is a verb or an adjective. It's the action that potential goes through when it's organized back into a symmetrical state. And so the ether, these little subatomic, you could say particles, basically like these tiny subatomic gas particles that are making up the ether, which is a substance in and of itself, is very homogeneous and symmetrical. The properties of it are the same in all directions as long as there's no influence of mass around it. And the whole key is to understand that this is the stuff. Potential is what the thing or the noun is, and the verb is when you organize the ether and create a asymmetrical condition of the ether, so there's a high and a low spot. Well, then you have a potential difference, and in electrical work it'll be a voltage potential, or in mechanical objects under the influence of the so-called gravitational field, which is really a gravitational push of the ether, and we'll go into that, is that that would be gravitational potential energy. And so it's measured in different ways, but it's all the exact same thing causing these potential differences. And so when you have the thing dissipate through resistances back to a symmetrical state, the activity of that dissipation is energy, which is the adjective or to describe the potential doing something, or is a verb to describe the action or the activity that the ether goes through on its way back to equilibrium or symmetry. And we're going to go into those in detail, but that's pretty much about all I want to say about the ether, just to keep it real simple, and we'll go on to the next chapters. Okay, in this section we're going to go over chapter 2, and again, this is not a full video presentation. This is kind of a brief overview, which you can kind of consider to be kind of a mild, a light tutorial for basically the content that you're getting in the quantum key, just to help put some thoughts together in a cohesive manner so you can make sense of it from A to Z and see how it all ties together. Now what I want to do is talk about the difference between potential and energy, and as I explained in the video clip on the ether, it's people use these backwards, mostly out of ignorance. So many people are using the term energy this, energy that. I'm talking about physicists and engineers, electrical engineers, mechanical engineers, the laymen, people in the healing arts talking about, oh, everything is energy, the universe is full of energy. Well, that's not true. The universe is full of potential, and there's only energy when work is being done, where you take an organized amount of potential energy and you dissipate it through resistances and you bring it down into disorder, and when it's completely disordered, then it's back to a state of potential energy. Okay, so potential is a thing, energy is the activity that the potential goes through. So no, sorry, the universe is not full of energy. The universe is full of potential to have energy if and when the symmetry of the ether is broken, or the symmetry or the ether is polarized, so you have a high and a low part. Now what we're going to do is look at potential and energy. Even the common definitions just simply don't make sense, because if you look at the word energy, it's usually defined as the capacity to do work. Okay, if it's the capacity to do work, then it's not work. And what does capacity mean? Capacity is potential, which is an ability to do something at some future point in time. So a lot of the common language in the dictionary is going to equate energy with potential, which is completely ludicrous. It's nonsense, and it makes absolutely no sense whatsoever. So you have all these kind of contradictions within the common language, and it's easy to see why so many people are confused, and they truly don't know what the difference is between energy and potential. That includes the physicists and the engineers, the academics and the laymen alike. So again, energy is usually defined as a capacity to do work. That means it has the future ability or the future potential to be able to do work at some future time. Okay, so what this is just showing right here is basically the language is all screwed up in the English language, and it's so convoluted with all kinds of nonsense like this that it's very difficult really to put it through the right kind of filters and then shake the garbage out of it to be able to see what's left standing, to see if anything makes sense. So energy is not the capacity to do something at a future time. Energy equals work. It is not the capacity or the potential or the ability to do work at some future time. Energy equals work. Now, work being done is not a noun. That is a verb that the potential goes through. So if we look at potential, a lot of people are conditioned to believe that potential is abstract. Like, look at little Johnny, who has such great potential to do good things in his life. Oh, look at little Jill. She has such great potential to do this and that. And that's, one of the more common ways that people relate to the word potential, which is in that context basically an abstract. But if we're talking about energy sciences and we're looking at what the ether is, how you even get the potential energy to have a potential difference to begin with, to be able to do work to begin with, to be able to manifest electricity or a moving object or whatever it happens to be, we can't think in those abstract terms because it's just magical thinking. Okay, it's complete nonsense. So what potential is the thing. It's the ether. It is the noun. More properly, when you actually look at it for what it is, you start to realize potential is the thing. Because inside of space, there is this infinite potential available. That potential is like in a flux where it's constantly fluxing in and out, and overall it's very symmetrical and homogeneous. That's just potential, and which is the thing. And when potential is dissipated through a resistance, then we say that is what energy is. And when you have energy, that's work. So for example, if we want to look at work, one volt times 1 amp equals 1 watt. Now 1 watt is not work, that's power. Watt is power. Okay, that's not energy yet, and that's not work yet. But if you take 1 watt and you multiply it over the period of time of 1 second, that means you're taking 1 watt of power and you're delivering it into doing some type of work for a period of 1 second, because if there's 0 seconds, obviously no work is being done. It's just a power measurement. So if you take the power and you multiply it by 1 second, then you have 1 watt second, or 1 joule of energy. Excuse the penmanship, but I think you get the point. That 1 watt has to be utilized over a period of time, and when it's used over one period of time, that is dissipated and is going to do a certain amount of work. And so work is measured in watt seconds or joules. If you're using electrical systems, you can measure it in watts, or you can say force times distance is going to be a certain amount of joules of mechanical work done to move an object from one place to the next. So all I'm doing here is basically just showing you that work, this is what energy is, because we know that work is measured in watt seconds, and we know that it's joules of energy, not joules of potential energy, which means the common definition for energy is erroneous, saying it's the capacity to do work. No, energy is work. So this is what work is. Work is taking a certain potential and utilizing it over a certain period of time, where an organized amount of potential is disorganized into equilibrium. And it's flatlined, and then it's in equilibrium with its environment. And then there's no more work. It's back to being symmetrical, and then it has to be repolarized to be able to do more work again. So anyway, this is what work is. Work is actually doing something, creating heat, moving an object, whatever it happens to be, and work equals energy. Okay, so again, just keep in mind that as you start to look at this, it's going to make more and more sense that potential, those tiny subatomic gas particles which make up the ether, which is a substance that propagates light through so-called vacuum space. It's not true vacuum because it's filled with the ether. And potential is the thing, and energy is the verb, or the action that potential experiences as it's doing work. Okay, and you can see the whole conventional mindset on this is completely backwards, where they see potential as the abstract and energy as a thing. That's wrong. Potential is the thing, energy is the verb or the action. And we go into more details in that in the book, in the Quantum Key in Chapter 2 on potential and energy. And I'll go ahead and end it right there. That just kind of clarifies kind of the main point there, and you can obviously read it in the book, and we'll go on to Chapter 3. Okay, in this section we're going to review a little bit about Chapter 3, which is on the dipole, which basically means two poles. Different systems can have 3 poles, 4 poles, 5 poles, multi-phase systems, but overall there's a high and a low pole that we're talking about, and this concept right here, which we're going to walk through a couple examples, is the basis, or you can say the foundational understanding for how you turn the ether into work. How do you get something very symmetrical and homogeneous sitting inside of space to actually do work? And that is by creating a dipole, which means, as I mentioned, Tom Bearden, for example, may say you want to break, the dipole breaks the symmetry of the virtual photon flux of the quantum mechanical vacuum. When you say it breaks the symmetry, that means you're taking it from a symmetrical state and you're making it an asymmetrical state where you have a high and a low point within that quantum flux, if you want to use that terminology. I like the ether terminology. I like how Eric Dollard says polarize the ether, because in simple terms that's exactly what you're doing, is you are polarizing ether. And that is what every dipole does, and we're going to go through a couple examples so you can basically see what this means. Okay, so let's take a look, and let's just say this is the ground, and we have gravitational potential moving down, and we'll get into what gravity appears to be later on, but I'm just going to show a simple example. So let's just say this is the ground. Now let's say on this ground we have a piece of wood like this laying down, and let's say there's a ball on this piece of wood right here. Does the ball roll? Well, if this is level on flat ground and the board is flat and that ball is just sitting there and it's a perfect sphere, and that ball will not roll because there is no dipole. There is no potential difference between here and here in relation to the board and its position to the ground. So if we took that board and we elevated it like this, we now have a potential difference between here and the ground right here, and mass times gravity times height, mgh, and we'll go over those simple little junior high school equations later. But what you've done is you've created a potential difference within the gravitational field. What you've done by creating a potential difference is creating a dipole. You have two poles, which you have a high pole here and you have a low pole here, which means as the gravitational potential is coming down, it can push on the ball, roll it down here. It's going to hit the ground, make a little bit of heat. You got a little bit of rolling friction here. The ball is going to roll over here. And what the point to this is basically showing that this is just one example of creating a dipole, which is two poles in order to take something that's symmetrical and getting it to do work. And many people are conditioned to believe that gravity can't do work because they're going to claim that it's a static field. That's complete nonsense, and we're going to go through that and completely destroy those arguments with nothing more than 3rd grade math and 7th grade Newtonian equations, which are the equations themselves give the right number, but they've been interpreted upside down and backwards. Conventional mindset has interpreted them inverse from what they're actually showing, and we're going to be going through those. And we'll go through some more examples of a dipole. So how does a battery work? Let's say you got a battery right here, and you got plates in here, and let's just say you got a negative pole here, you got a positive pole here. And let's say you got a light bulb in the circuit. Well, pretty much everybody is going to say if this battery is charged up, it's going to light the bulb and it's going to run out of charge. Well, the reality is that a battery doesn't run out of anything when it goes dead, and when you charge it, you don't fill it with anything. You're not adding or subtracting any mass or anything to the battery. All you're doing is rearranging the chemistry inside. And what I mean by that is when you charge a battery, you're separating the internal charges. When you run current through it, or you can actually do it with voltage potential, you can charge a battery, and that's what we do with Tesla at teslachargers.com. We utilize both. Is that when you're charging a battery and you're running current through it, what you're doing is you're taking disordered, symmetrical, homogeneous chemistry, in other words, and you're bringing the positive charges this way, and the negative charges are going this way. So when you charge a battery, all you're doing is you're separating the internal charges in the battery to create a high potential here and a low potential there at the terminal of the battery. So what is that doing inside of 3D space? Well, I shouldn't really say 3D because there is no such thing as three-dimensional space. Space is singular dimension. Space is one dimension, but there's three coordinates to be able to show the position of something within that singular dimension of space. And you really have to think about that, not too hard to see that that is actually what makes sense. And the reason is because if you're watching this video right now, if you're in a different dimension than I am, and dimension equals a different place within the same kind of space, if you're in a different dimension than I am, you couldn't even be watching this video right now. You couldn't go on the website, you couldn't mail something in the mail to me, because you're not sending a letter to me in a different dimension. You're still in the same singular dimension of space, but you are at different coordinates, and coordinates are not dimensions. Okay, now what we're looking at here is a high and a low potential. So what we're looking at is, if you have a battery here, and let's say you got the terminals right here, and let's just say the ether is very symmetrical and homogeneous, you know, all around the area of the battery. There's no potential difference, but when you charge the battery and you create a high, which is a plus, and a low, inside of that homogeneous ether, what you do is you break the symmetry. The positive charges of the ether move towards this pole here, and the negative charges of the ether are available here. So what happens is the ether organizes itself at these poles of the dipole, because that battery created an asymmetrical situation within that homogeneous and symmetrical ether. Just like lifting a board on the ground, you create a potential difference for the ball to run down. You create an asymmetrical relationship between that ball on the board and gravity. And what the battery does is it also creates a ramp. It creates a high and low point within the ether. So what happens with the ether is that the positive potential of the ether moves towards the positive terminal, and it flows over the surface of this copper wire this way back down to here. There's an implied anti-negative charge moving to the negative pole and moving backwards against it in that direction towards the positive. So where does the electron current come from? Inside of the copper wire itself, the copper has 3 electron levels. We'll say 1, 2, 3. And the electrons out here in that 3rd level are the most loosely bound. And because they're so loosely bound, it's easy for them to jump orbit. And so what happens is, as this positive potential, it's positive, this etheric flow, which some will say is the heavy side flow moving over the surface of the wire, it does not go through the wire, is positively charged, and what happens is a little bit of that is attracted to those electrons inside of the copper wire, and the electrons in the copper itself are attracted towards the positive charge, and they start moving in the direction of the positive terminal. So those electrons, which you're going to measure as electron current, is moving towards the positive pole, did not come from the battery because you never filled it up with a magical charge anyway. All you're doing is potentializing the electrons in the copper wire itself to be able to move towards that. Because the flow over the wire is positive, it's going to attract something that's negative, which are the electrons. And these electrons are moving very slow and sluggishly in the direction of the positive terminal. Very slow, couple inches per hour, only a couple inches per hour. And this is how a battery polarizes the ether. Now, part of this positive charge hits this positive terminal, comes in, or the negative charge, and it's going to come through here and eventually encounter organized negative charges. The positive comes this direction, goes this way, and encounters organized positive charges. So basically half of the potential energy you have here, the higher the voltage, the higher the ramp. The lower the voltage, the lower the ramp. Okay, so what happens is, as the light bulb is being lit, part of the potential energy there, see, that potential is moving over the circuit. And when it hits these electrons and you're getting this resistance in here, that's work. And what it does is it disorganizes the polarized chemistry in the battery back towards equilibrium, which means the voltage is going to start, if it's at 12 volts here, it's going to start going down. And when it goes down, down, down till it's dead, it doesn't go dead because it ran out of something. It goes dead because the chemistry comes into an equilibrium, which means the high charges are no longer here, the low charges are no longer here. They've equalized, and so the ramp is back down to laying flat down on the ground where there's no more potential difference for the battery to be able to do any more work. So that's an electrical example of what a dipole is, and I showed you the board with the ball. That's basically a mechanical example of a dipole. But in both situations, you're creating an asymmetrical situation for the ether, and the ether is the same whether it's for gravitational potential, whether it's for electrical, and this is where the potential comes to potentialize electricity anyway, is basically polarizing the ether, and that's how you get work out of it, and you do that through a dipole. So this is an electrical dipole, the ramp with the ball on it is a mechanical dipole, but the source potential is always the same. It's the ether from the environment. In this case, it moves to the terminal of the battery, then it flows over the surface of the wire, because the wire is like a waveguide. It's just kind of telling the ether where to go down to a lower potential. And then when you have a ramp, and let's say you got a ball and a ramp there and a ball and a ramp there, there's no potential difference there, but there is here. And when it rolls down here and it comes into here, there's no more potential difference, but it did work. So you're creating an asymmetrical situation for gravity to push down on the ball, because gravity is a push, it's not a pull. And in this case, the ether moves to the potential of the terminals, flows over the wire, and that's where you get your electricity. So this is basically kind of unifying the idea between gravitational potential and basic electricity, because a source potential is the same thing. The source potential is the thing. The source potential is that ether, which you take, and then you create an asymmetrical relationship between the ether and whatever you want to do work. And so it's all about polarizing the ether, and that's basically what a dipole does. There's more details in Chapter 3. And we'll go ahead and end this, and we'll move on to Chapter 4. Okay, this section is on Chapter 4, which is open versus closed systems. And this, in my opinion, is probably the most important chapter or concept out of the entire book, and it's the most important concept out of all so-called free energy research, because this is what makes the distinction that shows that free energy claims are not mysterious or woo-woo or wacky or anything like that. And in fact, what you're going to see is that the so-called crackpots have been conventional academia all along, because their model of thermodynamics actually does not represent anything in the natural world or the knowable universe at all. in any way, shape, or form, and you're going to see that. So the difference between open and closed systems is this. There are no closed systems. They just do not exist. There are no closed systems at all. Every system is open, but the distinction is some open systems are made to utilize potential energy outside of itself from the environment, and some are not. And we're going to look over those distinctions. So let's take a look at the light bulb, for example. And let's just say you got negative, positive, you have the you got the light bulb there. Okay, basic flashlight, right? And put a little switch here. Okay, when you close that switch, you have a light bulb lighting up, and now you have a little bit better idea of where the potential really comes from to do that. If you just watch the study the chapter on the dipole. So what you have here, this is typically going to be considered a closed system. In reality, it's an open system because the battery is under the influence of the ether, under gravity, gravitational potential. These wires are, the bulb is. This whole circuit is open to ambient light hitting it. It's open to air, wind, heat, you name it. But it is not set up to utilize any of that, and so it's considered a closed system, but in reality it's an open system. It's an open system which is not set up to take advantage of free environmental input from around it. Okay, so this is an example of a closed system. So if you charge the battery and you create a strong enough dipole to get up to whatever voltage potential you have X joules of potential energy available to you of work that the dipole can do, not that's filled up inside of the battery, but that the chemistry of the battery allows you to do over a certain period of time until the chemistry is equalized and then no more work can be done. Okay, so what you're looking at is if you have X units of energy, of potential energy, when heat and light are created and work is being done, the total amount of work that you're going to get cannot exceed what you're putting in here, okay? Because there's no other source of input. Let's take a look at a little different example. Let's say there's a child's top, okay, and let's just say it's kind of spinning around, and let's say it's sitting on the ground, and let's say you put 10 units of work into grabbing this, spinning it, and then you just let go. Well, this is an open system too, because it's open to gravity, heat, light, air, you know, whatever else is around you, the ether. But again, this is not set up to make use of it. It is a system that is cut off to taking advantage of environmental input, and it's solely based on what you're inputting. So if you put in 10 units of work, it's going to spin. You're creating heat and friction here. There's air friction here. You know, all that is work, and then pretty soon it's just going to wobble, and it's going to wobble until basically it's sitting on the ground like this. And when it's on the ground, it came into equilibrium with its environment. It is no longer moving, and this 10 units of work just dwindled down, 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 down until there's no more potential difference available. No more potential energy available to turn into work to keep the top spinning. So this is another closed system example. Now let's look at a basic open system. Okay, everybody has one of these, or most people have one of these in their kitchen. It's a refrigerator, and let's just say you have that plugged into the wall. Okay, there's a little ground prong there. Okay, that gets plugged into the wall, and basically you have heat going from the fridge and it's getting vented out of the fridge. Now inside of the compressor there's refrigerant fluid, and there's these compression and expansion cycles. We don't need to get into those details, but the concept to understand is that it's understood that heat moves for free towards a lower potential, or heat will move to cold for free. So let's say you put in 100 watts over time, which means it's not just a power rating, you're actually expending energy, or you're dissipating potential doing work to turn the compressor, and let's say you're spending 100 watts. Well, if you calculate the equivalent of all the heat in electrical work, how much heat was actually moved from that refrigerator to make it cold inside, you can see that easily it could be 200 watts worth of heat. You only contributed 100, but you did 200 watts worth of work. If that's 100 watts over an hour, you did 200 watts worth of work over an hour. 2 times as much. Because heat is the environmental input which moves to cold for free, and so when you calculate the total amount of work done, it is above and beyond what you paid for. Okay? This is more. You had a net gain in work created by the system, but you did not have to pay for that heat. Okay? Now this is one example of a open system. The systems with the top and the flashlight with the battery and light bulb, those are known as equilibrium systems. And the reason I say that they're known as equilibrium is because you have a certain amount of potential energy that dissipates through resistances which is going to manifest energy or work, and when it's done, it comes into equilibrium with its environment, and there's no more potential difference. There's no more dipole, so there can be no more work because there's no more potential difference. The refrigerator is an example of a non-equilibrium system. Why? Because if you have this system here and you put in 100 watts into here, but you got 200 watts of work done there, it's non-equilibrium because the heat in the system is contributing for free to work being done. When you calculate the total amount of heat movement, it's more than what you had to input. Okay? It's not more going out than going in, it's more going out than what you put in, which implies that there's about 100 watts worth here. So 100 and 100 equals 200. So it's not more out than in, it's more out than what you have to put in, because the extra input is free from environmental inputs. So what does the external environmental free potential input do? It keeps it from coming into equilibrium so fast, which doesn't prevent entropy, it delays entropy, so that the total amount of work done can be more when all is said and done compared to what you put in. Okay? None of this has anything to do with perpetual motion, none of it violates the laws of physics or anything like that. But the thing is in classical physics, this is actually recognized to be valid and legit, because it's known that in heat systems, heat will move to cold for free, and that's accepted that you can wind up with more work being done than what you had to pay for in electricity at the wall to move that heat. What's taboo is when you utilize that same concept for electrical or gravitational or other kind of systems. But the thing about it is if that concept only selectively works with heat systems but no other kind of system, then you know it's phony. And the reason I say that is because it has to, if it's going to be a law, and that's how thermodynamics works, it has to represent all systems, or it's selectively nitpicked just to apply in certain circumstances, and that's not science. That's a dog and pony show. Okay, so this is what non-equilibrium means, is that there's extra input coming in to keep it from coming into equilibrium, so the total amount work is more than what you put in. Now let's look at another non-equilibrium system, or a free energy system, which is not a heat system. Okay, so we're going to look at another example of a kid flying a kite, which is a non-equilibrium system. Okay, non-equilibrium free energy system, which is open to free environmental input. Now let's say this kid is flying a kite. There's wind coming into the system to help fly the kite, and let's say over a certain period of time the kid inputs 10 units of potential energy, or that was done through work, in actually getting the kite airborne. Now realistically, that kid, and this is a tail by the way, and so he could tie that kite onto a park bench and walk away and it would continue to fly if there's enough wind. But let's just say for a certain period of time he does put in 10, and let's say the wind contributes 90 parts work. Okay? So when we look at this, there's a total of input of 100 units of work. Okay? So total in equals 100 units of work. Now let's say that the kite design is so bad, there's so many factors going against this kid that he's really having a hard time flying it, and let's say an entire half of all this work going into it, 10 plus 90, an entire half of it is chewed up in losses because of bad kite design and whatever else. Okay, so we're going to say that there's 50 units of work which are losses, okay, but 50 is in flying. So the intended work of flying the kite is 50 units, okay? And so if we have 50 units of work divided by 100, that's 0.5, okay? Or 50% efficient, okay? 50% efficient. That's horrible efficiency, even though our cars might be lucky if they get 30% efficient. Solar panels are hovering around the low 20s that are easy to get. So 50% is actually pretty good considering those numbers. But fact is an example, easy numbers, half of all the input got chewed up in losses. It's a 50% efficient system. But it's a non-equilibrium system, it's an open system to free environmental input, so why is it only 50% efficient? How can more work be done, which is not some crazy perpetual motion claim or whatever else? Well, I want to make a distinction before I move on to that point, and this is the point right here, a very important point, which is these flying losses, these losses, and the flying is intended work, intended. Okay, so when you talk about efficiency of a system, it's the total work done, it's the total intended work done divided by the total input, and that gives you your efficiency. This is intended work, but all the losses is still work. Heat, friction, and everything else, which means 100 units went in and 100 units of work were accomplished. So in reality, every system is actually 100% efficient in converting all the input into work. It's just how much of it is intended or not. The intended is what goes into the efficiency rating. So that's kind of a little hoodwinking thing out there, talking about efficiency, completely making it look like the losses are not actually work. But this is an example to show that 100% input is always converted to work, but efficiency is intended work. Now, efficiency is one part of a measurement of a system, but I'm going to show you something else known as coefficient of performance, and this is how heat pumps are rated, but this is what we're going to look at. The total input here is total in equals 100. But for coefficient of performance, which is different from efficiency, it's the total amount in, okay, or actually we know that 50 parts of work were done. Intended work of flying the kite. Okay, so what we're going to look at is total work equals 50. And we're talking about intended work, okay? So if there's a total amount of work done, which is 50 parts of work, because the other 50 parts were chewed up in losses, 50 parts work were done, but how much did the kid have to pay for? Only 10 equals 5.0 COP. What that means is the child received a 500% net gain in work compared to what he had to put in. He received a net gain in work because all the rest came from environment for free. The wind is coming in, preventing it from going into full entropy or coming into equilibrium with its environment. Because if there was no wind from the environment and all the kid had to rely on was his 10 parts work, well, he's going to be worn out by the time he makes it to the other end of the field, because if he's not running and his work isn't creating the wind in relation to the kite moving through the still air, then he's going to dissipate that pretty quick. But free environmental input from the wind comes in to push this system out of equilibrium, so more work and more work and more work can continually be done, delaying, not preventing, entropy. Okay, so what we have here is the efficiency is 50% efficient, yet he got 5 times more work out of this system than what he had to pay for, just like in a refrigerator. That refrigerator example, that'd be a COP of 2.0 because the total amount of work done was 200 parts, but you only had to pay for 100 parts in electrical equivalent at the wall. So 200 divided by 100 is 2, which means it's COP of 2.0, which is actually pretty simple to get in a heat pump. And many of the geothermal heat pumps, some of them are getting up to 600-700% more than what you have to pay for electricity, because heat in the ground contributes free potential energy, and that energy is coming into the system, turning the water warm, and that gets pumped through your home, or it's pulling heat out of your home and depositing it into the ground during the hot season. But in any case, the COP stands for coefficient of performance. Okay, COP, and this is how heat pumps are rated. But all true free energy machines that output more than what you have to put into it operate under this over 1.0 COP concept, because it has free environmental input from the environment, delaying entropy so that more work can be done before it comes into equilibrium. And this is, the quintessential, open system concept here. And this is why systems that produce more, see, here's what the skeptics are always saying is, well, you can't have something, putting out more than what goes into it. Because they're ignorant of the distinction that there's not more going out than going in. There's more going out, 50 units of work, than what the operator had to put in, because there's free input from the environment. Okay, so that's the distinction that's very, very important, which is it is not more out than in. Okay, it's not more out than in, and people who claim more is going out than going in do not understand the distinctions. The skeptics don't understand the distinctions. Most of the academics don't want to admit that their argument against these systems have been wrong at the basic premise forever. There's not more out than in. There is more out than we put in, because that means that there's obviously extra environmental input to contribute to the total potential energy that's converting to work. And so it's more out than we put in, not more out than going in. There's more out than we put in, and that is the distinction. So when skeptics are talking about, well, you can only get out less than what you put in, everything is a closed, in a closed system, and they have all these ridiculous arguments, and you can kind of see some of these ridiculous arguments in the book, The Quantum Key. But hopefully you now have the distinction of what an open system is and what a closed system is. And some other examples of open systems. See, it's fine to talk about it in terms of finances and how communities organize and other natural systems. I mean, you put a little seed into the ground. Here's the ground. You put one little unit of energy to plant a seed, water it, and you walk away. And if there's enough, water and nutrients in the soil and everything else, you come back later, and pretty soon you have this, this monstrous tree right here that you didn't have to contribute anything. That's pushing up against gravity. there's heat, there's friction, there's wood is expanding, creating heat. It's utilizing nutrients. You're pumping fluids through the tree, and it's a ridiculous amount of work that happened all by itself, and you only contribute a little bit, which means the longer the tree grows, your coefficient of performance just continues to exponentially just climb and climb and climb, way more than anything that you put in. Okay, let's look at a financial system. See, a lot of people use the word synergy. Oh, it'd be such synergy if so and so got together and they did this and that, and but the concept synergy they may believe in, yet they're going to be the first ones to tell you that you can't have a system putting out more than going in. Well, synergy is, you talk about 1 + 1 = 3. It's more than the sum of its parts. This happens in chemistry and you name it. And actually it was back in 1977 that Ilya Prigogine, 1977, won a Nobel Prize in Chemistry for what's known as extending thermodynamics to include open dissipative systems or non-equilibrium systems. The open system examples I just gave you, those distinctions are clarified and made simple for pretty much everybody by Ilya Prigogine. Like I said, a Nobel Prize was given in 1977 for the work, but many physicists, engineers, and so forth, a lot of the academic world are completely ignorant of the distinctions between open and closed systems. They don't even know, and they're using closed system thermodynamics to explain natural systems like a tree growing, which is not a closed system. So those type of thermodynamics do not explain any natural system. Open system thermodynamics explains all the natural systems in the universe, and what's being taught in the textbooks about closed systems and the amount of energy remains the same in a closed system and all this nonsense. There are no closed systems, and those concepts apply to nothing in nature. Open systems do. And so many people have made an investment. You put $1 into something, and then you wind up getting, say, $2 out of it. Well, doesn't that violate the laws of thermodynamics? Well, I mean, that means there's extra input external from yourself to be able to wind up with more money than what you put into an investment. That is also a non-equilibrium system. You could lose money in investment, so just because a system is open does not mean you're always going to wind up with more than you put in, but what an open system does that's designed to make use of external input that's above and beyond your own is that if there is an open system, you at least have the possibility to wind up with more, okay? Because you can obviously lose in an investment, but this is just one example. Okay, so anyway, there's other examples on the open and closed systems in the book, and hopefully that clarifies enough to get a pretty good picture of it. But it's very important to understand that, because when you hear a skeptic talk about, well, you can't, it's impossible, it violates the laws of physics to have a system put out more than what's going in. Well, first of all, anybody making claims that they have a system that puts out more than what goes into it, they're ignorant of the facts as well. So it's not just the skeptics. A lot of people in the free energy, so-called free energy world, and the Tesla sciences and all this kind of stuff, where they're looking at making systems produce more than what you're putting into it, a lot of them don't even understand the distinctions. And so not only are the skeptics and the cynics, the pseudo-skeptics, doing an injustice to putting this knowledge forward, many researchers in the so-called free energy field, breakthrough energy field, are just as guilty, because they're utilizing language that they don't even know the distinctions. They're saying things are over 100% efficient, but in reality it's under 100% efficient, but it's over 1.0 COP. And they don't understand that it's not more going out than going in, it's more going out than what they have to put in. So hopefully this kind of clarifies it for you. And again, it's the most important concept I think you could walk away with in order to see that systems can easily produce more than what you put in. And I just want to show another example real quick. Let's just say this is a solar panel and we have the sun. okay, beating down on this panel, and then we get a certain amount of electricity out. Well, what is our input? Our input is 0, which means the COP is considered to be infinitely more than nothing. And solar power, hydropower, and wind power basically all have COPs that are basically infinite because you don't have to put anything into it. It's all provided free from the environment. The efficiencies are going to be low, like, the common solar panels are going to be in a low 20% range, yet it has an infinite COP because you don't have to put anything in. And just to, define a little bit about free energy, nobody dislikes this terminology more than the top people in the field who actually have machines. Because it's misunderstood. The free energy represents that free environmental potential that you can tap by creating an open system, which you leverage that free environmental potential to come into the system to delay entropy so that the total amount of work done is above and beyond what you have to pay for. Therefore, you have a COP of over 1.0, you have an efficiency under 100%, and you're winding up with more work than what you had to pay for. That is what free energy means, is that free environmental input coming into the system. And a lot of people these days, over the last X amount of years, in this crazy entitlement-minded mindset that they think that everybody else's labor and work and creativity and everything automatically belongs to them, they're starting to say, and not just starting to say, but it's one of the arguments saying, oh, well, free energy, that means that all these devices, the inventors need to make them and give them away to everybody for free to save the world, and all this ridiculous nonsense. And they're turning a term to represent free environmental potential into some financial term where they're trying to brainwash with their convoluted gibberish, trying to turn it into meaning that it's supposed to not cost anything. Well, obviously it's going to cost something. They'll say, well, there is no free energy because you have to pay for it. What they're talking about is you have to spend money to put it into parts and equipment to be able to build it, and so essentially it doesn't cost you nothing. But I don't like to use that term, and I don't like to use that example because it is understood that it is free environmental potential. Yes, you do have to make an investment, put something in, but we're looking at it from in terms of a potential and energy system standpoint, which basically means, yes, there is free energy and it represents free environmental potential. So when you hear anybody talking about, well, free energy is supposed to be free as far as not costing anything, and that people who are coming up with different innovative technologies are supposed to just give this stuff away to everybody for free. Why? So they can go on welfare and be a burden to society like too many other people. Well, that's just not going to happen, and that's out of touch with reality. And so free energy does not mean that. Free energy means a free environmental potential, because we're talking about open systems. And a lot of the skeptics are talking about, well, that would be perpetual motion. Well, is the kid flying a kite who just got a 500% net gain in work compared to what he had to put into it, is that kid flying a kite? Is that perpetual motion? But they're gonna say, oh, well, that's a perpetual motion claim that he's getting more out than in. So you can see the astounding and staggering amount of ignorance that is just running rampant through the whole academic field. And you got all these people who think that they're qualified to discuss these things, but they don't even know the difference. They don't even know the difference. So nothing to do with perpetual motion. No laws of physics are broken. The child got 500% net gain compared to what he put in. Period. End of story. It's indisputable, and it can't even be debated. Well, not with any rational sense anyway. People can debate all they want. But if they want to try to debate it for the purposes of disproving what I just explained, then they're just going off into some nutcase kind of realm which has no relation to reality. So anyway, hopefully that'll help you out a little bit, and we'll end that section and then we'll move on to the next chapter. Okay, we're in chapter 5 on the bouncing ball. This chapter has probably infuriated more people than anything, so hope you enjoy it. This is actually a long chapter that goes into quite a few different concepts. A lot of it ties into gravity, which there's a separate chapter on gravity. We're going to go over some of those concepts anyway, so there might be a little redundancy. But in any case, there's some important concepts here that I really want you to get as far as potential energy, which is work, the relationship with each other, and what's really happening in simple systems, basically that interact with gravity, for example, and we'll go over a little bit about that. So one of the common things that's claimed quite often is that you get out what you put into it. So let's say this is the ground. Let's say you got an object here. Let's say you lift this object to this height, okay, and force times distance is going to tell you how many joules of work were done, real work, to lift this object. Then, when you let go of it, that object is going to crash down onto the ground and will release an equal amount of work as what you put in while you stored it when you lifted it to begin with. So if it takes a joule of energy to lift this here, you get a joule of energy out, and there's no net gain in work. And that is the convoluted madness shared by academia for so long, and it's so completely ridiculous, and it's an embarrassment to the entire academic world, I believe, that they keep perpetuating this nonsense when you can simply prove it with third grade math and seventh grade equations. And we're going to go over some of those examples. And you're going to see the lies, the deception with very basic things around us to keep people from really seeing what the truth is and what's going on here. Okay, so we're going to go into an example here. Let's say that this is the ground, and let's say you lift this object to here and you did 1 unit of work. And then let's say that the ball is dropped and it comes down here and you get a unit of work out, because they're going to say you can only get out of it what you put into it. But we're going to destroy this nonsense here shortly because it's a plague and a mind virus. So let's look at this. Okay, they're going to say you have plus 1 units of work here, and then they're going to, and some of them are going to say, well, but you have negative 1 amount of work. So if you add these two, positive work and negative work, you wind up with 0, which means there's no net gain in energy happening. Wow, let's just magically make positive work disappear and make it look like negative work. Well, the fact of the matter is heat is created in your muscle to lift this, or in a bulldozer, or whatever it happens to be. Work was done because force times distance, force is mass times gravity, and then times distance is going to tell you how much work was done to lift it. So there's a calculation to tell you how much work, which is real energy, which is entropy, which created heat to lift this object. 1 unit. When this object drops and it comes back to the ground and it makes an impact, a deformation of the mass, or heat on impact, that is also positive work. And so some of the schools of thoughts out there in the academic world are going to brainwash people into believing that you got positive work here, negative work here, so there's a no net gain in work. And they're just making it disappear by putting a minus sign here. And I've seen some differences between the schools of thought, between people who were schooled in Europe and people who were schooled in the United States, and I see what the skeptical arguments are, and I see that, you know, for the most part, they're kind of on the same page, but there are little distinctions in there. But for the most part, both schools of thought completely just makes this disappear, and makes the real answer disappear. This created heat. This created heat. These are both moving forward in time, contributing to entropy of the universe, and this is not negative work, because to have negative work, that means you're not creating heat and a dissipated energy. What you're doing is you're attracting heat and you're cooling something down and you're reordering it, and that's negative work. Are you doing that when you're dropping an object and creating heat on the ground? The answer is no, it's positive work. So the correct answer is you have positive 1 work plus positive 1 work equals 2 units of positive work. Why? Because it's an open, non-equilibrium system, open to free gravitational input, which means your input is 1 plus gravity contributed 1 unit of potential, gravitational potential energy, which mgh, mass times gravity times height. You can see that. mass times gravity times height of this object will tell you how many joules of potential energy are supposed to be stored in the object. Well, the truth is there's no such thing as storing any potential whatsoever. There's only creating dipoles, so you have a potential difference, so the environmental potential can come in and do work. You don't store anything. Okay, but in any case, MGH is going to say there's an equal amount of stored potential gravitational energy that is equal to the work done to lift it. Well, they're admitting this is work, force times distance, which is a positive 1 work that you put into the system. And what did you do? By the time this object is lifted to the height, there is nothing to store because you just used up all the potential energy. You used 1 joule of energy. There is nothing left. If it took 1 joule to lift this, how can you be storing and how can there be anything left when you just, because what you get out of the object by lifting it is the lift of the object in and of itself. You can't store anything that you just used up. You dissipated it back to the environment, which means when this object is here, there is no potential energy stored in it. What you did is you created a dipole, which is a potential difference between that object and the ground, and this height right here multiplied by the gravity multiplied by the mass of the object is going to tell you how many joules of potential energy are available from gravitational potential energy if and when the object is released, for the gravitational potential to push on the mass, push it to the ground, meet resistance, create heat and dissipation. And so the energy came from gravity, because gravity is not a static field. Gravity is a very dynamic force, which is basically the ether, and we'll go into that in the gravitational chapter. But you put in 1 unit of work, you got an extra unit of work out. Okay, that's 2 units of work. You get 2 units of work, okay, and you only had to pay for 1. That equals 2.0, which is COP of 2.0. What is the efficiency? Well, that can be calculated as well, but the point is that in nature you always get a freebie, okay? You always get a freebie. That means you put 1 unit of work in and you get another unit of work out of it, okay? So when they say there's no net work, it's false, because what they're trying to do is, this object is right here, it moved here, and when you get it here, it came back down and it comes to the same place, so there's no net distance that it traveled. Well, yes, there is. There's this distance here, and then there's this distance here. If you're at your house right here, and you take a little stroll and you go over this distance to the store to buy some milk and eggs, and then you turn around and do a return trip and you get back home, are you going to tell me that you're actually going to believe that there was no net work done because you simply made it back to the same position? It's the same, it's as ridiculous, okay? And so what they're doing is they're turning a distance or a vector type of situation where you have a +1 this way and then a +1 this way. That'll sum out to 0. Okay, but that's just showing a distance going this way and a distance coming this way is 0. And what they're doing is they're taking this and they're trying to tell you that that represents work, but it does not, because work is force times distance on the upwards lift. That's real work. That's entropy, okay? And when it dropped and hit and made impact on the ground and created heat and friction through the friction and everything, that is also work, which was predicted by MGH, which equals force times distance. So you got 2 units of work, and when they say, well, you got this much here, and there's no net, they're turning that vector deal of saying, okay, this is going right here, and it comes right back down, and it ends in the same exact place, so no net work is done. Well, that has nothing to do with work, but they're trying to teach. That's what they've been teaching forever. Since any of us watching this video were ever born, that's the type of garbage that they're teaching, to say that there's no net work, but that doesn't even explain what work is. Work is lift up. When it drops and impacts, you add those together, and that's the total amount of work. 2.0 COP, nature always gives you a freebie. I just want to take a second to mention Newton's cradle, which is kind of used as one of the quintessential examples of demonstrating conservation of momentum and other nonsense like that. What's completely ironic about the Newton's cradle is that it violates conventional physics. See, if you have the frame here, okay, sit on a table, let's just see, you got these balls here like this. See, what they're going to say is you lift one out and you drop it, okay? And it hits here, and ball at the end is going to swing out up to here, and when it gets to its peak, it's going to come down, and gradually, little by little by little, it kind of winds down like this, okay, and until it comes into equilibrium. It is an open system, but what's interesting about this is that, see, there's no such thing as conservation of energy, and there's no such thing as conservation of momentum. Because if you lift an object, you can calculate how many joules of potential energy were dissipated as work to lift this ball to this height. When you let go, there's impact, heat, friction, and everything. And what happens is, when it gets down to the bottom, there is nothing left, right? Except for when you take away the losses, that momentum or kicks that ball up to a height that's less than this. But what happens is, when this ball comes up here to this height right here, when it comes to the peak, 100% of every bit of potential energy is dissipated back to the environment, and there is nothing stored in it. There is no momentum stored. There is no energy stored. All that happens is that it comes up here, it dissipates all potential energy. There is nothing left to store, and there is nothing stored. There's nothing conserved. It's all dissipated right back to the environment. When the ball starts to come back this way, okay, you have your basic equations to show you how much potential energy is available in that object at that height. Gravity comes in fresh each time to push this down, to hit this, to get this to lift up to a level that's maybe not as high next time. But when it gets up to this height, 100% of all the potential energy is dissipated right back to the environment. No momentum is stored, because the momentum from this object hitting this and hitting that and going in that direction, all the momentum has completely disappeared on the other end. What you have is, you established a dipole where fresh potential energy comes in, pushes on it to do work, bringing that up to here. That is new momentum. It's not conserved momentum. It's not new. It's not conserved energy, because nothing was conserved in the system. On each cyclic system like this, you have X amount of potential energy, because you have a potential difference, which is, through different resistances, is doing work, okay? And then what happens is that the system kind of regauges itself, or creates a new potential difference. It may not be as high of a potential difference, but it's a new potential difference, which means all the potential energy is dissipated. Fresh gravitational potential energy comes into the system to do brand new work, which means the potential energy to do the work, to bring that ball this way, to hit that, to swing these up, is completely different from the energy that went into it to begin with. See, energy does not change forms, okay? They say energy cannot be created or destroyed. It only changed forms from one form to another. That's completely false, because the only thing that ever happens is that energy is created out of thin air, so to speak. What happens is, when you establish a dipole, free gravitational potential comes in and you do work, you got that energy. Energy was created by simply creating a dipole and tapping the potential from the environment. That pushes the ball down. It goes up on the other side. There's no more energy, no potential to store, nothing. There is no conservation of energy. It's 100% dissipated when it gets to the peak of its lift. You created a dipole. See the difference between here and there? You created a new dipole so that you have a potential difference for fresh gravitational potential to come in, push it down, which means that work right there is created, and then you destroyed energy through the process of bringing it into equilibrium. And you have no more to store. You have nothing to store, because you used it all up. 100% of all the potential energy minus all these losses to push that ball up is used up to lift the object, and there is nothing else left at the peak of that lift. Nothing else exists. You created a lower potential between the ground, because with losses, then fresh gravitational potential comes in, pushes it, brings it not so high, and then 100% of everything is dissipated back to the environment. There's nothing conserved, no momentum is conserved, no energy is conserved. You destroyed all the energy. You created a brand new dipole which is not as high. Fresh potential energy comes in, pushes on it, brings it back up here to not so high. 100% of all the potential energy is dissipated. There is nothing conserved. You destroyed all the energy. You created a new dipole, which is with a little bit of loss, right? Not as high of a dipole. So that fresh potential energy comes in, pushes it, and that cycle repeats. So the process that happens in all these cyclic type systems that utilize free environmental input to have over 1.0 COP is that you create a dipole, okay? When you create a dipole, you have a potential difference. Then you do work from the potential energy coming into the dipole. It's all dissipated, and then you basically create a new dipole. For fresh potential energy to come in to do more work, and then you create a new dipole. Okay? So nothing is conserved, nothing is maintained, energy is created and destroyed cyclically because nothing is conserved within the system itself. Everything is 100% dissipated on each cycle. You create a new potential difference for fresh free environmental potential to come into the circuit to do more work. And that happens like this until it comes down into equilibrium. Delaying equilibrium, not preventing it, so more work can be done than what you have to basically put in. But what the Newton's cradle basically shows is not momentum or conservation of energy. It's the opposite. It shows the creation and destruction of energy, and it shows that there is no such thing as conservation of energy, and there's no such thing as conservation of momentum. You destroy and equalize and dissipate all the potential energy you had available on each cycle, created a new dipole for fresh potential to come in to do new work each time. So each time one of these cycles happens, none of the energy is the same it was ever conserved or used again. It's completely fresh from the environment. And that's also a very important concept to understand. Okay, chapter 6 on mass I'm basically going to skip over because it's such a short chapter and it doesn't really add a whole lot to the concept that I'm tying together between the ether, gravity, inertia, and these concepts and the dipole. You can read it in the book. The next chapter is 7 on gravity, and we'll get started on that. Okay, so this section is on chapter 7, gravity. This is probably maybe my favorite concept in all this because it's pretty fun and it really ties together a lot of things. And so we'll go and get started there. So gravity is always seen as, you know, this mysterious gravitational pull, which really doesn't exist. It's a gravitational push. And so basically appears to be a displacement concept where, let's just say, for example, you had you have a bathtub, okay, and the water level is, you know, up to whatever level. And let's say you take like a bowling ball and you submerge it in the water. The water is going to rise so that to make up for the area that ball is occupying. It's going to displace the water by that amount. Now this is inside of a gravitational field and everything, so it's not the perfect analogy, but if you put a bowling ball into a tub of water, the water is going to rise. It's going to be displaced by the volume of that ball. But the water is also pushing back on that ball from all directions. Let's say this is the planet Earth, floating in space, which is ether. See, space is not filled with ether. Space is the ether. There is no space without the ether. If there is no ether, then it's a true vacuum, and a true vacuum is a true void, which is not space at all. And we'll get into a little bit of that later. So let's just say this is a planet Earth floating in a sea of ether. So what happens is that the planet is displacing the ether. Not like the bowling ball example where that's displacing it by volume. This is really displacing it by mass, because the volume is irrelevant because different masses have different densities. Okay, and so what happens is this is displacing the ether, while the ether is pushing back towards the center of the mass that displaced it. Okay, this ether, tiny gas particles are coming down, gets a little bit more dense. They can create different particles that basically rise to the surface, like artesian water, electrons, or whatever your favorite particle idea is. And so it's this constant dynamic motion, so it's not static. And these particles are created, and the ether is constantly replacing and trying to maintain an equilibrium by pushing down on the mass, turning into particles, coming out here, and you have this constant movement like this. And we'll look at some simple examples so you can see that. Okay, so let's just say this is the surface of the planet. And let's just say on the planet, on the surface, you have two cubes, 1 cubic foot. Let's just say one is wood and one is lead. Okay, they're the same volume, so to speak. They take up the same space or the same coordinates of 1 cubic foot. The wood is very spacious, which means the so-called atomic matrix is very spacious. There's a lot of empty space. Even in something dense, most of it's empty space anyway, but this is just for a simple example. So the wood is very spacious. The lead is very dense compared to the wood. So as the ether is rebounding back towards the center of the mass that displaced it, what it's doing is it's pushing on the protons that make up the mass of the object, holding it to the ground. So if you take this block of wood and you try to lift it up, there's more empty space for the ether to move through, which gives less resistance, so it's going to feel a certain weight. If you take this block of lead and you lift it up, well, there's a lot more mass, a lot more protons for that ether to push on, and less empty space for it to make its way through, which means when you try to lift it, it's heavier. So that's why the wood is easier to lift than the lead, and they're equal volumes, and that's basically what gravity is and how the weight is caused. Another way to look at that is, let's look at a river. Let's just say you have a river moving in this direction, and let's say you have a net with 1 square inch spacing. And if you took this net and you moved it against that flow, well, you're not going to really reach much resistance because the water can easily flow through these big gaps. But let's say you had a net with like 1 millimeter mesh, and you try to move it through, you're going to get a lot more resistance, aren't you? That's because there's a lot more mass, or a lot more stuff for the water to push on to give the resistance. And that's the analogy that basically shows you why the wood and the lead have different weights when you try to lift it up against gravity. So gravity is not a gravitational pull at all. It's a push by mass displacing the ether, and the ether is rebounding back to the center of the mass. Okay, and that's basically what gravity is. You know, when we have this going on, let's say you have light from a distant star, whatever the reality to light is, you know, almost nobody knows. But it's known to bend towards by large objects, okay, because of gravitational pull. Well, it's not a gravitational pull. What it is as this light is moving in this direction like this, the reason the trajectory is changed by a large object is because as the ether is being pushed down like this, the ether gets more dense towards the surface. And what I mean by that is, let's say you have an object here. Well, the ether is real dense here, and then it starts getting lighter out here until it's basically like at an equilibrium out here where the mass isn't influencing it anymore. So the further you go from the mass, the less influence, and the closer you get, the more dense it's going to be right on the mass. And so as the ether is pushing down, the ether that the light is traveling through is becoming compressed, it's dense, and you're going to hear, oh, the ether is incompressible. Okay, that's true to a point, but there are different densities of the ether, okay? And it's not to be confused, and a lot of people do confuse the concept, because you can have an area where space is compressed, which means the ether is compressed. It's the same amount of ether in a smaller volume, so to speak, which means it's denser. So as the density of the ether here is being pushed down and densified down here, that means that the ether the light would normally travel through is actually pushed closer to the surface by being dense, and that is why it deviates on a different trajectory. Now let's look at gravitational attraction and why large bodies are attracted to each other. And these concepts work in consciousness with how people are attracted to each other through synchronicities. My model basically has unified consciousness with the physical world, and that's kind of a different topic. But anyway, I'm just going to go through gravitational attraction between large masses. So let's say you got a large mass here and the ether is rebounding here. And let's just say, you know, the mass is perfectly symmetrical, which means the push is equal from all the way around the object. Okay, and let's say you got another mass. And it's symmetrical and the ether is rebounding equally all the way around it. However, let's just say this mass is a little bit smaller. So let's just make that more obvious. Let's just say it's smaller like this. The ether is rebounding back to the center from where the mass displaced it. Okay, and let's say these objects are near each other. Let's just say this is like a big star and this is a planet or something. Why does this get attracted to here? Well, the reason is because although this is symmetrical all by itself, if it's away from everything, and that's symmetrical all by itself away from everything, if they're in close proximity, the ether between them in this area here, okay, in this area, in this region of space, is divided between both of them. Which means there's only so much ether, so it has to be divided proportionally by this mass displacing it, which means you're going to have a little bit, let's say this has a strength of 5, 5, 5, 5, 5, just to make a real simple example. But let's say because of this, let's just say the push on this side is only going to be about maybe a 4. Okay, well, let's say proportionally this is 5, 5, 5, 5, and let's say, you know, this is, or, you know, let's say maybe those are like 2s, right? Okay, and that's like a 1 or something. What it means is the ether in this area is distributed between and divided between these, which means the push on this side of this mass and the push on this side of the mass is less than these, and this push is less than what these are. And what that does is it pushes them together, because this creates an asymmetry. Okay, you're breaking the symmetry of the displacement, and what you're doing is you're going to create an asymmetrical situation where if the push of the ether is the least on this side, that means you get all this push here, which is going to push this object in this direction. This push on this side of the object is weaker than this side, which means the ether is squeezing down and is going to push the object in this direction, and that's why they move together. Just like if you had like a bar of soap, let's say this is a wet bar of soap, and you grabbed onto it and you squeeze down right here. And if you squeezed it equally all the way around, that wet bar of soap is not going to move. But if you squeeze it like this with one hand, and you're squeezing it like this, well, it's kind of common sense that that bar of soap is going to be projected in that direction, right? Because there's the weakest push or no push here. Well, you got all the push on one side, so you created a asymmetry there, or basically like a dipole, so to speak, because you did create a potential difference. With these, this is how gravitational attraction happens. You divide the ether proportionately based on the masses, and the push back on the mass is less here and less on the facing sides, which means the outside sides of the ether is rebounding and pushing down on that mass harder than it is between here, so you asymmetrically push them together, and that's what gravitational attraction is. Okay, now we're going to get into chapter 8, which is inertia, which is kind of the sister to gravity, and we'll make this really simple as well, so you can see what inertia is and its interaction with mass. So let's just say the ether is, fairly symmetrical out here. Let's say you got a mass right here. It's not moving or anything. We do have the rebound back because you got the gravity on that mass. Okay, but away from that mass, the ether is fairly symmetrical. Okay, and evenly distributed and homogeneous in a very symmetrical state because you're not creating any asymmetry within this. Okay, and the ether has a certain rebound equally all the way around this mass. Now, let's just say we start to speed this mass up. If we have this mass and we move it in this direction and we accelerate it, what happens is the mass encounters more ether. Let's take these 6 lines of ether to represent a certain amount of space, for example. And let's say it's more dense. And if we accelerate it even more, okay, and pretty soon we accelerate it to the point where this mass is, the ether becomes so dense. Now, is it actually dense or is it like apparently dense? See, it's relative, and I'm not getting into relativity to back Einstein because most of Einstein's work is phony, it's fraudulent, and his claims are upside down and inverse from reality. We're going to clarify a little bit of that. But this mass, as it's accelerating through here, if it's still and the ether is very symmetrical and evenly spaced and everything out here, and that's one thing. But when you accelerate this, it's encountering more space per unit of time, which means relative to the mass, the ether is becoming very, very dense. And what that does is that ether imparts a resistance against the protons that make up the mass, resisting its movement as it's trying to accelerate faster and faster. And that's what resists mass movement through space, and that's basically what inertia is the ether imparting a counter push against the mass that's moving through it. And the faster the mass goes, the more space it experiences per unit of time, which means the more ether it's experiencing per unit of time. So let's take an example of something really simple to see how time factors into this, relevant to the observer. Okay, and so the gravity and inertia, the reason those type of things happen are because of the ether, not because of the lack of it. It's the ether which is the connecting medium that makes sense of it, and not like the isolationist, compartmentalized mindset of Einstein that makes you want to believe that everything is separate from each other. It's not true. Everything is connected at very profound levels, with the ether being the common medium that connects all of it. So let's just say that you have a planet here and you got a big planet here. And if you're standing on this planet here, or you're standing on this planet here, time is going to, and let's just say the densities of all the mass that make these up are the same. Let's say they're equal in elements and everything else. The density is the same per unit, per volume. It displaces the same amount of ether, but you just have so much more displacement happening here than you do here. And so what happens is this will be slow and this will be fast. Now let's say this person and that person are both looking at their stopwatches, or looking at a wristwatch, and to each of them from their own perspective, time looks like it's ticking the same, or it looks like it's ticking normal. They don't know that there's any difference. But if you had an omnipotent, absolute view where you're not subject to the ether and its influences, and you compared both of these, this one is actually ticking faster than this one. Why is that? The reason this ticks faster is because the ether that is being displaced and rebounding towards here is not as dense as this one, where this is displacing a lot of ether, which means you're getting more density against that as it winds up less. You know, it's just a lot weaker. Or this is weaker and this is stronger, which means because of the density in here, it's restricting the movement of time itself, which is nothing more than motion of mass through space. So what this is showing is the density, the higher the density, the slower time ticks. The lower the density, the faster time ticks. An example that I want to give you is, let's just say, you know, and the same thing is with mass traveling through the ether. As it accelerates, let's just say it's not going very fast, and let's say this one is going super fast, where per unit of time it's experiencing a lot of space. Okay, this is going to be slow and this is going to be fast. Okay, gravitational and inertial equivalencies here, and so sort of. And so what you're looking at is, if this is not going very fast, this reference to fast is time ticking, that slow is time ticking. But the object is moving slow here, which means there's not very much density to restrict the movement, which means time is going to tick fast. This object is moving very fast, encountering a lot of etheric density relative to the object, which means it imparts a lot more resistance. Therefore, time is going to tick very slow. So these type of relativistic effects are possible because of the ether and not because of what Einstein clowned around and turned it all into. His original model was an elastic etheric model. He admitted that none of this can happen without the ether. So that's basically the basics of inertia, and I just want to mention E equals mc squared. This is all hogwash. There is no such thing as mass-energy equivalency, because energy is not intrinsic to the mass itself. If you have mass and you're accelerating this mass and you're encountering a lot of ether out here, and that imparts a lot of push on the protons which make up the mass to create a resistance against its movement through the ether, energy is always imparted, or the potential energy to be dissipated into work and create a resistance or whatever it happens to be is imparted from the environment to the mass. There is no mass, there is no energy which is intrinsic to mass itself. Okay? It just does not exist. And that's one of the phony things, is because if you believe in the Einstein hoax, you would have to believe that gravity is static. You believe in magical, mythical ideas of storing potential. You don't need to store potential. You create a potential difference so that free environmental potential can come in. You're creating a potential difference is what you're doing. And there's no need to store potential because you don't have to, and you can't. There's no way to store potential. Okay, and so anyway, these are the basics of inertia and gravity, and hopefully you can kind of see how those tie together. Okay, chapter 9 is on time. Very simple concept. It's one of the most convoluted subjects ever in the history of the world. What is time? Oh, there's 3 dimensions of space, and then there's time, which is the 4th dimension, and a bunch of other mumbo-jumbo, which makes absolutely no sense, has no basis in reality. There is 1 dimension to space, that's space. There are 3 coordinates within that. There is time, which can be a mathematical dimension, but what I'm going to show you is actually what the operating mechanism is that is time, and I already kind of explained a little bit about it with gravity and inertia, but it is really simple. It's not magical or elusive like everybody wants to claim. So let's just say you have a, you know what a rubber band propeller is, or a rubber band airplane, where you twist up a rubber band on this little plane and let it go, and it'll just unwind really quick. So if you had one of these rubber band powered airplanes, okay, let's just make the wings, and here's the rudder there. There's a little rubber band airplane, and let's just say this is water, and let's say this is gelatin. Well, water is very thin, gelatin is kind of thick, but if you took this rubber band propeller, wound it up a particular amount, and if you submerged it in this water, there's not really much resistance to it unwinding, and it's going to unwind fairly fast, so time is going to tick fast because there's not much resistance to its movement. If you took that same airplane and you put it in some gelatin, well, it's going to be real slow and lethargic as it's trying to unwind and unravel through the resistance of the gelatin that's pushing against the propeller, slowing it down, and so basically time will tick slow. So what time actually is mass moving through the ether. Even if there is no mass, time is relevant to each person because they're subject to that area of density itself. If somebody is in low density, time ticks fast from an absolute point. If somebody is in a high density etheric density area, time ticks slow. Why do they not tell the difference on their own clock? Is because if they're in a, let's say you're in a low density area, and let's just say this represents a high density area of ether as it kind of gets lighter. Okay, is that inside of the area, whether it's a high density ether or a low density ether, light is going to adjust to the density of the ether. So as light is propagating through this medium, from an absolute point of view, light is going fast here and light is going slow here. Okay? Light is constantly changing speeds depending on the ether, the etheric density that is moving through. Okay? Because if you take a certain amount of ether and you compress it into a smaller unit, what that means is that there is more resistance to that light moving through from an absolute perspective, which means it's going to be slowing down. Time ticks slow, time ticks fast here, and light is moving faster through here. Okay? If somebody is here and somebody is here, okay, if you're inside of this area right here under this high density, you don't know the difference because your conscious perception, the speed of light, everything, your movement, how fast your heart is beating, all these different variables taken into account, everything is proportionately slowed down based on the density of that ether, which means light is slowed down, but you can't tell a difference because your conscious perception can only operate at a speed that your neurons can fire, and all these different complicated factors all put together creates a really complex web that seamlessly kind of fits together. But what it does is your perception is slowed down because everything else is slowed down. Light is slowed down. The blood pumping through your body is slowed down from an absolute perspective. From your own perspective, it all looks normal. Plus, under a high density area, things are going to change size from an absolute perspective relative to something else in a different density area, but you're never going to tell. So if you had if you're standing perfectly still and you had a 1 meter yardstick, but you're in a place of high density ether here, and let's say this is low density ether, and this yardstick is 1 yard, if you put that yardstick in this area, it's only, from an absolute perspective, it's only going to look like it's 1/3. See, because you have to take the same amount of space and you have to compress it proportionally. Okay, so let's just say it's 3 times the density. From an absolute perspective, it shrank 3 times, but so did you. Light slowed down 3 times, and everything is going to be proportionate to that, and that's why it's going to look slow. So if you just go back to the rubber band propeller idea, it's going to unwind and be able to move fast. See, time is just an incremental measurement to measure movement from your own perspective, and that's all it is. See, a clock doesn't measure time, it's just an incremental movement. If you have a child on a swing, let's say this is a swing set, okay, and you got a little kid here swinging on a swing set. If that kid swings at an equal periodic beat, 1 second, 1 second, 1 second, and if you can get an equal graduated marking to indicate every time that kid is swinging, that's just as valid of a clock as a regular clock to keep time. So what that shows is the clock doesn't measure time, and if people's idea of time is the Earth's position relevant to the sun, that makes absolutely no sense. All it is time is nothing more than a graduated incremental measurement of motion, and that's it. The higher the density, the slower things move. The lower the density, the faster things move. And that's basically what time is. And you can create negative resistance effects where there's no inertia at all. And all these ideas about wormholes and that kind of garbage, you can just toss it out the window, because we can look at interacting with mass and inertia and the ether in logical, simple ways to show how you actually can shield yourself from the effects of inertia. And we'll go into that in the next chapter. But hopefully this gives you a little perspective about what time is. We already went over a little bit about light speed, which is going to be based on the density of the ether that it's moving through. So it's constantly speeding up and slowing down. And so if ether is leaving a high density area and then it enters your area at a lower density, it's still always going to be looking like it's moving at the speed of light. But what we're going to do is use that measurement, and we're going to extrapolate from that and say, oh, well, it must have traveled X distance, when in fact we have absolutely no idea what it is, because we can't measure what the speed was while it was traveling through a different density, because it's constantly adjusting based on those densities. So when we look out into the universe, we don't know where the high or low density areas are, and we don't take into consideration what is the distance that it's traveling, from an absolute viewpoint, because we can't get out of the relativistic perception very easily, and so that complicates things. But in any case, they make all these constants and everything, and they don't even understand the interaction of light through the ether and how that it does change according to the density of the ether. And so in the next chapter we'll talk about extraluminal travel. Okay, chapter 11 is on extraluminal travel. That doesn't mean faster than the speed of light. It means outside of the constraints of light speed brainwashing, basically. Because there is a difference between faster than the speed of light and then instantaneous, which is not faster than the speed of light, it's instantaneous. It's a completely different concept, and we'll just go into this concept just briefly. So, let's say you have a ship, and this isn't like an aluminum sphere or shell or whatever it happens to be, and if this is moving in this direction through the ether, okay, well, at a very high rate of speed, it's going to have a lot of etheric density to contend with, because that is creating the inertia on the mass of the ship and its contents. And what that's going to do is create resistance to its movement. I mean, that's what inertia is. So how do we get around that? And knowing that there is this substance, the ether, which imparts a push on the mass to create inertia, how do we get around that? So basically, an idea that I came up with long ago, and I've come to realize that there's some other schools of thoughts out there that actually kind of sort of predict the same thing. I don't know at what level, but this is my independent idea, and I found out that there are some experiments that actually give a little bit of credit to these concepts. So anyway, let's just say you have a shell right here, and let's say you put a super ultra high voltage potential here, positive, and a negative potential there on the shell of the ship. Well, what's going to happen is with the ether, let's just say that the ether is out here. The positive potential of the ether is going to be repelled from the front leading edge and is going to be attracted over the shell towards the negative. Okay, you're deflecting it over the shell so that in the negative charge, the implied negative charge is going to be attracted and pulling on this positive edge. Okay, so what happens is the ship is going to move in this direction. Without even knowing it, I came across some research by T. Townsend Brown and the Biefeld-Brown effect, and showing that there's these capacitors that when they put positive on one end, negative on the other, it actually does move in that direction. And those are looking like that type of technology evolved into stuff they're using on these stealth bombers and stuff that can fly silent because they're some type of electrogravitic propulsion through space. And I believe this is basically hitting on that kind of concept. But what this is doing is if you have a high enough voltage potential here, you're deflecting the ether over the shell, which means it's not moving through the shell. If it can't move through into the mass, there can't be any inertia. And so the positive potential of the ether is deflected around the shell towards this negative end, like this. But the negative implied anti-charge of the ether is pulling on the positive right here, which means the negative charge of the ether is actually sucking this along, so that what it does is it creates like a true vacuum right here that the ship is, that's engulfing the ship, which means the ship is traveling without going across any distance, because what makes distance is space. Space is the ether. If you deflect the ether around an object, the object is not traveling a distance because it's not moving through the space. Space is slipping around it. Okay? So these ideas about exceeding the speed of light or going from one place to another through these wormholes and all this kind of nonsense, this is what makes sense based on kind of what we know. And so it's basically, instead of moving into a positive resistance that's butting heads, it's being pulled along and sucked at a negative resistance. Because again, the negative charge of the ether is going to be pulling on this positive and is going to be pulling it along at a negative resistance. And what I mean by negative resistance is, let's say you have a wind tunnel, and let's say you have a little paper airplane and you throw it into this wind tunnel. The moment you throw it into this wind tunnel, let's just say you got this paper airplane like this. When you throw it into this wind tunnel, let's say there's no wind flowing through here or anything. There's just ambient air in here. If you toss this in at 1 mile per hour, it's going to hit the air, create resistance, and you're going to get these, you know, eddy currents and stuff, I guess you could say. But essentially, you know, the wind, this plane is just going to go like this until it basically just drops, because it's hitting positive resistance of the air and it's causing it to do all this kind of business. But let's say that there's a big propeller blade or a fan over here moving this way at 1 mile per hour, the same speed. What that's going to do is that's going to suck a smooth flow of air through here at 1 mile per hour. So if you had the paper airplane here and you toss it in here, you've removed the resistance. Not negative resistance, you remove the resistance because the flow is already established at the same speed that you want to drop this plane into this tunnel, which means it can just steadily glide right through at really no air resistance very much, because you've neutralized it. So the first example, it's pushing into a positive resistance. This is taking away the resistance. But let's say you have this tunnel. Let's say that's a big propeller at the end, blowing it, say, 5 miles per hour. But you have this paper airplane and you throw it into the tunnel and you just toss it at 1 mile per hour. This paper airplane, you just threw it at 1 mile per hour, but it's going to accelerate up to 5 miles per hour at a negative resistance, which means it's being pulled along faster than its own speed at a negative resistance. So this is like a negative resistance. So if you want to look at the shell of the ship, positive, negative, where the ether is being deflected around like this, okay, space is literally going around the object. The object is slipping through space, which is the medium that light travels through and is the medium of space and is of itself. And so it's being pushed along like this, where this can propel in that direction, but the ether does not go through the mass, which means that there's no inertia. And that's how it can instantly go from one point to another point, utilizing these type of concepts without having any inertia whatsoever, because it's being pulled along at a negative resistance. Okay, chapter 12 on free energy solutions. I'm not going to go into this. It's kind of a long chapter with a compilation of a handful of technologies that most of them I've had personal experience with. I don't just write about them, but I build them. I know many of the inventors. And any of those models, prototypes, or anything else that you see in there have basically been built, and they operate on the concepts of the open system thermodynamics, which means they can produce more energy than what you have to put in, because they are leveraging some type of environmental input to be able to come in to delay entropy so that the total amount of work done is more than what you had to contribute. There's quite a few of them. At the at the Energy Science and Technology Conference, which is Energy Science and Technology Conference, which is Energy Science Conference.com, is an annual conference that we're probably about one of the only breakthrough energy conferences where we actually show so-called over-united devices or free energy devices that produce more work than what it takes to run them. Last year at the conference, John Bedini showed one of his little motors that has a couple little old corroded D-cell batteries, which don't even act as batteries anymore. They act as dry cell capacitors. Basically the thing is dead. He turns the rotor, and after about an hour it's running about 30% faster than at the beginning, basically keeping itself charged up. He showed another machine known as a Cromray generator or a G-field generator, where you attach a light bulb to it, and the more you try to draw from it, the faster it runs. And it also gets cold and starts blowing cold air, which is the complete opposite of creating heat. A lot of these kind of things are shown there. 5-6 years ago, he showed a big 14-foot wheel, which was spinning on three 36-volt batteries, three 12-volt batteries for a 36-volt battery bank, and on the back end he had another 36-volt battery bank taking all the recovery. And what happened was basically ran through the whole conference, and the voltage of the batteries never dropped. Okay, these are the kind of things that you can learn at this conference, and the quantum key is really just to kind of put these ideas together to make it simple for the layman to understand that free energy claims are not some type of hokey, crazy perpetual motion claims, and has nothing to do with perpetual motion. As you can see, it's very rational, it's very simple to understand, and it's really very common sense after the fact, once the distinctions are pointed out. And you can see that it does not violate the laws of thermodynamics, does not have anything to do with perpetual motion, as many of the academics want to claim that these kind of things would be impossible. We do have the distinctions and the parameters, and if you want to learn basically from the pioneers of the modern day Tesla and breakthrough science energy movement, this conference is really the one to come to. You can take a look at our other websites. A lot of them are linked to from these other sites. Okay, and we'll finish this video. I just want to give you one link here, which has a compilation of all my major links, and that's Murakami, my last name, LLC.com. It has links to the forums, the conference page, other books and videos, Tesla chargers, and some other stuff. And I even have a TV station on Roku, and available elsewhere, and there's details on that. I've actually never even announced that to my own network, just kind of quietly put it out there. but you can find the links on there. So anyway, hope you enjoyed some of that, and that helps clarify or makes it easier to understand what's in the quantum key. Thanks for watching.